Good morning, everybody, and welcome back after what I hope was a lovely half term. We're going to continue with our work on time. I have a new setup. I have a new camera. I have a new light. You can see my table, and as you can see, I'm wearing a lovely blonde wig. I'm not going to wear this for the whole video, but as Mr. Jarman is currently winning our competition by having the pink tiara that he wore in his last video last term, I figured I would do my best. And I'm running out of hats, so blonde wig and the tiara was the best I could find. However, it's really itchy, so that's going to come off. And I'll do the rest of this video with really bad hat hair, or really bad lockdown hair, depending on what you want to call it. Anyway, so time. We're going to move on to really looking at clocks. That's our intention for today. Now, if you were in school, I would all give you one of those little yellow clocks. They're about that big. Got quite a few of them in school. And the hands move and they're sort of stuck to each other. I can't give you those because they're at school and you're not. However, depending on what you can do at home, could make this easier or harder. What I did, and I'll send you the file, is I found a clock that you can print out. Now I stuck it to a piece of cardboard I had that I stole from my daughter's craft box, but printed it out and I stuck it down. It's got these two little handles, or hands, sorry, which you have to cut out, and again I stuck them onto cardboard. I didn't have a split pin, so I've just taken a paper clip, bent a bit up on the paper clip, poked it through a hole. Be very careful. Probably a good idea to put a bit of plasticine or a bit of Play-Doh and then push into it rather than pushing into your hand. That's a good way to send it through a finger, or ask a grown-up to do it for you. And again, the same with these. I would put them on a piece of Play-Doh or something and then push the end of the paper clip into them, or ask a grown-up to do it. And what you get when you put it together is a clock. Now, unlike the clocks at school, where when you move one hand, the other hand moves because there's cogs behind it, these ones move totally independently. Which means we really have to understand how clocks work for these to work. Okay. Now, I've been teaching children to read clocks for quite a few years now. And it's always a hard one. It's always a tricky one. I spent a lot of time thinking about why. Why is it so hard? And the reason it's hard is that clocks are frankly ridiculous. I mean, look at this thing. It's got numbers around it, and it's got these little lines, and they've put extra numbers in here, which is lovely to help us count them up. And it's got two hands, and it's all very, very weird. And in a day where, let's see if I can get my watch to open. In a day where we have a digital clock that shows the time nice and sensibly like that, this clock seems weirdly out of date, but they are still around and you still have got to understand them. So, let's think about, well, why do they do what they do? Well, they go around in a circle. Why do they go around in a circle? Why do they go around that way? Why do they go clockwise and not anti-clockwise? And it turns out that if you're in the northern hemisphere, so the top half of our planet, which is where we live, and you had a sundial, that's the direction that the shadow would move around the circle of the sundial. And the sundial had to be a circle to work. So when clockmakers were making the first clocks, that was the shape they went for. But why two hands? I mean, that sounds weird. That looks very, very weird. And the reason being, if I pull this on from the side here, they didn't have two hands to begin with. This is a picture of a very early clock. And you'll notice that there is, the hand goes underneath it because it's not really there, just one hand on this clock. It's the hour hand. And actually, when you stop and really look at a clock, if you understand how a clock works, you only really need the hour hand. The minute hand was added later on by, let me get his name right, I've Lost it now. Jost Bürgi, who was a Swiss clockmaker and mathematician. He did it for an astronomer, because astronomers needed to know really specific time. But most people, through most of the time that clocks have been around, when this clock here was around, didn't need to know very specific time. You needed to get up at about the right time in the morning, and you needed to go to work at about the right time. But if you worked on a farm, the animals didn't really care if you were a minute or two late or a minute or two early. So clocks didn't need to be super accurate, which is why if I take the minute hand off of this clock will still work perfectly well. Let's ignore the entire outside of the clock. Let's just look, I'm not going to cover that up. Let's just look at the numbers in between. These points here are the hours of the clock. So we start at midnight, and the hour hand is there. And it takes 1 hour to go from there to there. And if you want to know how much past the hour you are, well, you just see how far it's gone. If it's there, it's nearly 1 o'clock. If it's there, it's nearly still midnight. Let's look at some sensible times we'd actually use during the day. Let's imagine we're getting to the end of the school day. We want to know when it's 3:15. Well, it's 3 o'clock when the hand points there. It's 4 o'clock when the hand points there. So when's 15:15? Well, that bit there is the hour. Halfway between the two, when it's 1/2 past. Quarter way between the two, and it's 1/4 past. 3/4 of the way through between the two, and it's 1/4 to, because it's nearly at the next one. So actually this hand is all we need. And if a clock was big enough, and they could mark 60 little marks in between here and here, that would be all we'd ever need. But that's all people did need for a very long time. You're meeting a friend at about 2, well, you leave just before the hand gets to 2, gives you enough time to get there. You want to have your tea, let's say about 5:30, well, you wait until the hour hand is halfway between the 5 and the 6. If that's all a clock was, teaching children to read clocks would be a really easy job, and I wouldn't spend so much of my time stressing about it. Parents wouldn't spend so much of their time stressing about it, because teaching children to read clocks is not just something teachers do, it's something that parents do as well. So why do we need this extra hand? Why did this come along? Well, if you're an astronomer and you want to track what the planets are doing, what the stars are doing, and you need to know exactly what time they reach certain places, you need to know to the nearest minute. And when you're here, you're saying that's about halfway between 2 and 3. It's about 2:30. But is that 2:30, or is that 2:30? Or is that 2:30? Or is that 2:30? It's very difficult to see. By the time you get to here, well, it's nearly 3 o'clock, which is pretty much all you need to know if it's, I need to go and feed the cows at 3 o'clock. But it doesn't really help if you're an astronomer that needs to know exactly what minute it is, and other jobs need to know exact minutes as well. Now, in real life, people would have an hourglass. I think we've all seen hourglasses, we've got them at school, like the egg timer things, where sand starts on the top and it pours down to the bottom. That tells us how long a period of time is, but it doesn't tell us what time of the day it is. And that's fine for most jobs. If you're a baker and you know that you want to be home by 4, perhaps you'd start baking your last thing when the hand gets about here, because you know that's most of an hour left. And if you want to time how long the bread's in the oven, use an egg timer. You start it when you want to start it, it finishes when you want to finish it. But if you need real accuracy. So this astronomer, Tycho, I can never pronounce his name, Tycho Brahe, and his clockmaking friend, they looked at this and they said, well, I need more accuracy. So let's stick this hand on. And the deal is that while this hand is going from here to here, this hand will do one complete circuit. Now, it'd be cool if they put them on two separate clock faces. If one hand told us how close we were to the hour, and then this one kind of zoomed in for us. That's not how they did it. They decided to put the two, one on top of the other. So we've got this hand here, which is the minute hand. It's a long one, and it reaches to these outside numbers, which are my minute numbers. So when this reaches 1 o'clock, this hand, minute hand, is here. As this moves round from here to here, this one does it really big and exaggerated. Really much easier to read. So by the time it's halfway, this big hand has gone halfway through its journey. By the time it's 3/4 of the way, this hand has gone 3/4 way through its journey. And then if we move little tiny bits here, it becomes much bigger bits here. That means you can look at this minute hand, so it's hour hand, and say, well, oh, it's nearly 2, but I'm not quite sure how nearly it is 2. Well, this hand here tells you. So what I think I'm going to do for your work today is I'm going to give you some clocks to begin with that don't have the minute hand on. It's very important that you can read a clock by the hour hand alone. It will remind you that hour hands move. They don't teleport from here to there, to there, to there. And I've had years where I've got children to draw clocks, and they'll draw the minute hand in the perfect place, but the hour hand only ever points at an hour. Sometimes you find online clocks that do that, which is really naughty. So your first piece of work will be, what's the time from this? And I wanted you to estimate the time, because you can't know exactly, but you know close enough. So that would be 1 o'clock, that would be 2 o'clock, that would be 3 o'clock, that would be 4 o'clock, that would be 5, that would be 6 o'clock, that would be 7 o'clock, that would be 8 o'clock, that would be 9 o'clock, that would be 10 o'clock, that would be 11 o'clock, and that would be 12 o'clock. And we've got to go this way around, because that's what clocks do, because that's what sundials do, because that's what the sun does, and there's nothing we can do about it. That is 12:30, or that is 2:30, that is 3:30, that is 8:30, that is 9:30. Did I say 8:30 there? Or there? That's 7:30. That's 8:30. 9:30. 1/4 is about there. I reckon if that's 9, that's about a minute past, a couple of minutes past. That's about a couple of minutes to 10. Again, it's much easier to say how close it is to 10 than how far away it is from 9. That's why we do that 1:45 thing rather than 45 minutes past, because if you're just looking at this bit, the moment it gets halfway, it's closer to the next bit, so it's easier to judge than the next bit. So 9, 5 past 10, no, not 5 past, 1, 2, 3, 4, 5 minutes past, maybe 15 minutes past there, 9:15, and that's about 9:30, about 9:45 there, 15 minutes to 10, and then that's 10 o'clock. So that's like a minute to 10, 10, minute to 10, 10, minute to 10, 10, minute past 10, 10. Okay, I want you to read a clock just by the hour hand. When we've done that, then we'll start being more accurate, and we'll say to ourselves, let's do some work with the minute hand, but not today. That will be another lesson, because that way you will really know what this hand is for, and then you won't make the mistakes I hope that I see every year with clocks. Fingers crossed. Okay, as always, I'll send you the work. If you've got any questions, just let me know. I'm looking over here because that's where my face is on the screen, but actually you are there, aren't you? So if you have any questions, just let me know.